theorem. This is the theorem that we'll be using in this exercise 8.2. Alright, so let us understand with the statement: the line segment joining the midpoints of two sides of a triangle. So which is a line segment here? EF is a line segment, alright, joining the midpoints. So remember, these are the points, midpoints of two sides of a triangle, which simply means that E and F are in the middle, alright, of a triangle, is parallel to the third side. So it simply means that EF is parallel to BC. Okay, now that EF is parallel to BC, right, these two lines are already parallel, then I can say that angle E equals angle B and angle F equals angle C, right? And once again, because these two are the midpoints, therefore AE should be equal to EB and also AF should be equal to FC, right? Midpoint. The last thing you have to understand is remember that this EF is half times BC, right? So for example, if the question gave us BC to be equal to 8, then this will simply be 4 half times, alright? So that is what the midpoint theorem states. Okay, now suppose let's take another case. Let's say there's a third line, you can see here CG, right, that is parallel to AB. Alright, these two lines are parallel. So remember that EF is half times FD, alright, and also EF equals FD. Clear? Okay, that will do for a midpoint theorem. Now let's go to the question. So the first question: ABC is a quadrilateral. You can already see four-sided, right? PQ, R, and S are the midpoints, right? So remember, this is a midpoint of all of the four sides. AC is a diagonal. We have to prove all this, right? So let's go one after the other. So the first we have to prove is SR, this line is parallel to this line. Also, SR is half times AC, right? So let's go here. So the triangle we will be considering will be the red ones, right? In triangle DAC, we already know that S is a midpoint of AD and R is a midpoint of CD, right? And for the midpoint theorem, can I say that SR is parallel to AC? I can say. Also, we can say that SR equals half times AC, all because of the midpoint theorem. So that is our first proof, alright? Now let's go to the next. Here we also prove that PQ equals SR, right? So here we'll be taking the lower triangle again, right? So remember that this P is a midpoint of AB and even Q is a midpoint of BC, which means I can say that PQ is parallel to AC and also PQ is half times AC, right? Why? Because of the midpoint theorem. Now when you look at from 1, okay, in 1 what did we get? From 1 we got that SR equals half times AC, right? And we just got this. Now look at the right hand side, half times AC, half times AC. Can I say the left hand side will be equal? I can say, alright, so PQ equals SR. That is our second proof. Let's go to the last. Now the last we'll be trying to prove that PQRS is a parallelogram, right? Now we already got this, right? PQ is parallel to this PQ is parallel to AC, and also we've already got that SR is parallel to AC. That's from both 1 and 2, right? Now when you look here, can you see that AC, right? PQ is parallel to AC and SR is parallel to AC, which means even these two lines has to be parallel and equal to each other. Now, which means what? That we already got here that PQ equals SR, right? And also that these two lines PQ is parallel to SR. We already got it here, right? From 1 and 2, right? Now I can say that this quadrilateral is a parallelogram. Why? Because opposite sides are equal and parallel to each other. Therefore we can say PQRS is a parallelogram. Let's do one more, question number 2. So ABC is a rhombus once again, and then PQ, R, and S are the midpoints of the sides of AB. So just like a previous question again, these are the midpoints, and remember that ABC is a rhombus. Okay, so we also prove that this PQRS, you can see here, right? And this PQRS is a rectangle. We also prove. Okay, so the given ABC is a rhombus and PQRS are midpoints. Write down. We also prove it is a what is that? It is a rectangle, right? So construction, what we will do, we'll just have to join this AC, right? The diagonal. Clear? Now look here, we'll take one triangle after the other, right? So first in triangle ABC, the red ones. Okay, can I say that P is a midpoint of AB and also that Q is a midpoint of BC? They've already, the question already gave us. All right, then according to the midpoint theorem, can I say that PQ is parallel to AC and also PQ is half times AC? We can say. All right, now let's go to the next again. Once again, we'll take the upper triangle and try to prove. Okay, So now in ADC, once again, I know that this S is a midpoint of AD and R is a midpoint of CD, right? That means I can say SR is parallel to AC, and also that this SR equals half times AC once again. Why? Because of the midpoint theorem, right? Now consider this 1 and 2, right? So I just written for us here both 1 and 2, right? So can I say that from 1 and 2, because see, AC, right? That means can I say that PQ is parallel to RS? I can say, right? If they're parallel, obviously they will be once again equal to each other, right? Therefore you can say PQ equals SR. If when you look at their right hand side are equal, right? Which means PQ should be equal to RS or SR, whatever you want. Okay, so now from here, what did we get? We're getting that this PQ is parallel to RS or SR, whichever you want, right? And also we know that this PQ is equal to SR. Right, now you can see that opposite sides are equal and parallel to one another. Alright, one pair of opposite sides is equal and parallel. Therefore, I can say that PQRS is also a rectangle.